Hey folks, welcome back to another video. Today we're looking at question 32, longest valid parenthesis. The way we'll be solving this problem is by using a stack, and also we'll keep a track of the left pointer. So basically the left pointer, what it does, it keeps a track of from which point we should actually start counting. And then there are a lot of cases, so let's walk through those cases, and then we can start coding. So in this question, there are only two different characters that can appear, right? So either it's the opening or the closing parenthesis, right? So we keep a track of the index of the opening parenthesis in the stack, right? But if we see a closing parenthesis, there are a couple of cases that we need to keep a track of. And the three cases are the current stack is actually empty, right? And if the current stack is not empty, but we actually pop it, and what does that look like? So let's walk through all of those cases. So when the stack is empty, that means there's nothing that actually closes that. That means you can use this point as a restart, as in like you can reset the left pointer because, hey, you know what? You're saying you can recalculate starting from this point. So that's when you actually reset the left pointer when the stack is empty. If the stack is not empty, there are two cases that you need to take care of. First is you pop it and it is empty, which means that if it is empty, that means you've actually gone through the entire thing in the stack, and using the left pointer that you've updated previously, you calculate the entire distance between the opening and the closing parenthesis, right? But if it is not empty and there are more values in the stack, but you can't really pop it, you just peek into whatever is in the stack, and you try to calculate the distance. So you try to find the local maximum. I hope that makes sense. It's a lot easier to understand this by going through an example. I would highly recommend going through the examples that you see here and coming up with your own test cases. But let's jump into the solution now, right? So what are the few things that you need? Let's start with the base cases, right? So if s is equal to null, you would just return 0. The other thing you need is also the size of the string. S dot length. Actually, let's just calculate it here. S dot length. If it is equal to 0, you would actually return result, which is 0, which is fine. And here you actually keep the size of the length. If it is not 0, what else do you need? You need the left pointer. We actually initialize that to -1. And the reason why we initialize that to -1 is because all of the indices, they start with 0. So the reason why you start with -1 is because it provides an extra 1 that takes care of the fact that 0 cannot add that 1 to the distance. So that's the reason why you add it as -1. Do we need anything else to get started? I think that's good. So after that, you just have a for loop that goes through all of the characters of the stack itself. Didn't initialize the stack. So let's call it stack integer stack to new stack. Okay, so start with I less than size increment I, right? So if s dot character at I, if it is equal to opening parenthesis, you just add that to the stack. So let's do that. Stack dot push I. So you're just keeping a track of the index. Else, there are a couple of things that you need to check, right? As soon as you get in, you need to check if the stack is empty or not. If a stack that is empty, if it is not empty, actually let's handle that test case first because it's a little more complicated. Else, so whatever we need to do. If it is not empty, you handle there. If not, you need to reset the value to left to be I. Right, so basically you're saying we saw a closing parenthesis, and the thing is we don't have anything to match that. That means we need to reset the left pointer. So you reset the left pointer to be I. And once you, and in this test case, right, if the stack is not empty, you actually pop the stack to match it, the opening and the closing parentheses. And at this point, if the stack is empty, you basically recheck this. Okay, so in this case, if it is not empty, that means there are more opening parentheses that need to be matched. So you just need to take the local value and you need to reset the value. So result will be equal to that maximum of result that we've already seen, or I minus stack dot peak. So what are you saying here? You're basically saying, hey, you know what? Just figure out the last time you saw an opening, like an open parenthesis, and just match it, because that will give you the result of all the parentheses that actually match within those two boundaries. So you have that here. If this doesn't happen, if the stack is not empty, if the stack is empty, that means you need to recalculate from actually the left. That means everything has been popped, everything matched, and the way you actually calculate the distance is by using the left pointer that you initialized before. So that would be dot max of the result that you've already seen, or it would be what is the maximum here? It would be I minus left, I think. Yeah, I think so. Okay, yeah, that makes sense. All right, so let's try compiling this and see if this is okay. S dot length dh. Okay. Oh, of course. And in the end, you return the result. Okay, so the first test case is okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity of the entire solution. The space complexity of the entire solution is of n, since we are using a stack to keep a track of the indices. And the time complexity of the entire solution is O of n, since we have to go through each and every single character in the string to actually come to the result. Awesome. If you have any problems with the solution that I just laid out for you, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I would really appreciate that. It definitely motivates me to make more videos. Thanks so much, and I'll see you all in the next video. Peace.